All right, everybody. So in order to complete this assignment, you're going to need to go to your email and download the file that I sent you if you'd like to print it and complete it on paper. But if you just want to write down the questions and work along with me, that's also fine, but please do that. You need to work through these. That's just part of what's going on. So right here, it's asking us to simplify each expression, and it's assuming all variables are positive. So this means we're not going to need those absolute value bars as we're simplifying. So I've got bases of 5 here, and when I'm multiplying exponents with like bases, I just add. So this is going to give me 5, and this is going to be 5 to the power of 1/3 plus 2/3. So that's 5 to the power of 3/3. So that's 5 to the power of 1. So our answer here is just 5. So when we go along to our next problem, we're going to be multiplying our coefficients and then adding our exponents here. We've got 1/4 plus 1/3. So let's go ahead and turn these into 12ths. So I have 2y to the 3, ooh, that's not a 3, to the 3/12ths times 3y to the 4/12ths. So 2 times 3 is going to give us 6. So that's going to be 6 times y to the 7/12. So that's one way we can write that. Another way is we can do 6 multiplied by the 12th root of y to the power of 7. So those will be equivalent values there, but again, we multiplied and then we added. So again, we did 1/4 plus 1/3, and we ended up with 7/12. So that is what we have there. So when we go into the next one here, we've got like bases. So we've got -11 as our like base. We're adding 1/3 plus 1/3 plus 1/3. So that's going to be to the 3/3. So that's -11 to the power of 1. So our solution is -11. All right, continuing along here. So this negative, remember, is applied after the exponent. So I'm multiplying y to the 2/3 by y to the 1/5 and then applying the negative. So this is going to give me negative y, well, 2/3 plus 1/5, we're going to need some like bases again, or common denominators. So we're going to go with 15. So this is going to be 10/15 times y to the 3/15. So this is actually going to give us negative y to the 13/15. And that is equivalent to negative the 15th root of y to the power of 13. So again, pretty ridiculous answer, but it is what it is. So here I'm multiplying 5 and 1/4 by 5 and 1/4. So I'm going to add my exponents here. That's going to be 5 to the 2/4. Well, that's 5 to the power of 1/2. Well, that is going to be equivalent to the square root of 5. So again, that's simplified. So I go to this next one here. I'm going to multiply my exponents here by adding, then my coefficients through multiplication. So I get -21x. I've got 1/6 plus 2/6. So that's to the 3/6. So that's -21x to the 1/2. So that is -21 times the square root of x. So those are your first problems there. So again, go back and watch any parts of those that you need to see again, but we're going to move on to the back. All right, so on the back here, we're going to be working with entire quantities being raised to certain values. So these get a little bit messy, but we're going to be all right here. So um, obviously, we know that this is now taking some sort of power and raising it to a power. So we are not looking at adding like bases anymore. So right now, we're going to take this exponent of negative 1/2 and we're going to apply it to each piece of our monomial here. So this is going to be 16 to the power of negative 1/2. This is going to be x, well, that's 2 times negative 1/2, so that's going to be x to the negative first, and then y, and then 8 times negative 1/2, so that's going to be y to the negative fourth. So right now, I know that I have a whole bunch of negative exponents right now. So when I have negative exponents, what I do is I flip them over some sort of denominator or into some denominator of a fraction. So my 16 to the negative 1/2 is going to become 16 to the positive 1/2 down here. My x to the negative 1 is going to become x to the positive 1, and I'm not even going to write that. And then my y to the negative fourth is going to become y to the positive fourth, and up here I'm going to have a 1. So I'm getting pretty close to being simplified here, but I still have 16 to the power of 1/2. And in order for it to be in simplest form, I can't have any fractional exponents anymore. So I actually know that 16 to the 1/2 is the square root of 16. Well, the square root of 16 is just 4. So I actually have 1 over 4 x y to the power of 4. And that is my simplified exponent problem there. All right, so we're moving along here, and in this one, we're just taking this entire quantity, negative 243, and raising it to the power of negative 1/5. Well, I want to take this entire thing, and I want to take that quantity and have negative 243 raised to the power of positive 1/5. So this is actually 1 over the 5th root of negative 243. So we know that if we have an even index, we can't take a root of a negative, but here we have an odd index, that's 5. So we can use our calculators to find the 5th root of negative 243. So we press 5, then we hit math, then we hit 5. We type in negative 243, and we get that the 5th root of negative 243 is negative 3. So our answer here is negative 1/3. So we're going to go into this next one here. I have 2 raised to the power of 4, and then 1/2, or I have 1/4 now being raised to the power of 4. So that's going to be 2 to the power of 4 times x to, well, 1/4 times 4 is 1, and 2 to the power of 4 is, well, 2 to the power of 3 is 8, and then 8 times 2 is 16. So our solution here is just 16x. All right, team, so we're going to keep on simplifying here. I'm going to change my color because the orange is starting to annoy me. You're going to be doing a lot of math in purple because purple is my favorite color. And they don't really give me a lot of options here, so I'm just going to go with what I got. So we're going to go on to our next one here. This is again another monomial being raised to here a positive exponent. So at this point, most of us have realized that raising something to 1/2 is the same as taking the square root of it, but here we go. So we've got 25 raised to the power of 1/2. We're going to be multiplying here and here because that's our power to a power rule. So this is going to be 25 to the power of 1/2 multiplied by x. Well, negative 6 times 1/2, that's going to be negative 3 times y squared to the power of 1/2. That's 2 times 1/2, so I've just got y. So this is going to give me 25 to the power of 1/2 multiplied by y. Well, this is going to flip to the denominator in my fraction, so it's going to be x to the third power. Well, the last thing we need to do is recognize we can't have this fraction here. So this is the square root of 25 multiplied by y over x to the third power. So the square root of 25 is 5, so this is going to be 5y divided by x to the power of 3. So that right there is your final solution. So you can see that solving these is actually some sort of combination of using exponent rules and the conversion of exponents to radicals in order to get your final solution. All right, so let's continue. So right now we are going to take 2/3. We're going to just put it on the 8 there. We're going to do -3 here to the power of 2/3 and then 9 to the power of 2/3. So when I'm going to take 8, I'm going to raise it to the power of 2/3 a. So this is going to give us -6 divided by 3. So that's going to be a to the power of -2. And then we're going to have b. So 9 times 2 is 18. And 18 divided by 3 is 6. So I've got b to the power of 6. So right now I automatically know that this -2 needs to swing to our denominator, and at some point this is going to have to get converted to see what we can do with it. So let's go ahead and look at that piece now as well. So I'm going to make my fraction here. B to the power of 6 is going to stay in the numerator. This piece here is going to drop to the denominator as it's negative. And then this is a cube root, and it is the cubed root of 8 squared. Well, interestingly enough, that is the cubed root of 64 multiplied by b to the power of 6 over a squared. Well, the cubed root of 64 is 4. So summer math, guys, it matters. I know it's been a while, but the cube root of 64 is 4, so that's 4b to the power of 6 over a squared. And that right there is going to be your final solution. All right, so this is the last one. So you've got a negative exponent here, so you can already anticipate you're going to be doing some flipping. But remember that this is going to be end up being a square root of 16, a square root of 25, so we're not actually looking at anything that bad. So when I have this exponent on the outside here, it's got to go to every single piece on the inside. So I'm actually applying this exponent of -1/2 4 times. So this is 16 to the power of -1/2. This is not going to become a negative number. That is something that people confuse all the time because you think about a positive times a negative. This isn't times a negative, so I want you to be really careful with that. So this is now 4 multiplied by -1/2, so that's going to be z to the power of -2. Then this is going to be 25 to the power of -1/2. Again, this is not going to become a negative number. And then this is going to be x to the power of -4. So every single piece here is negative. So what that means is our fraction is going to completely flip to its inverse. So I'm going to have 25 to the power of 1/2 over x to the power of 4 over 16 to the power of 1/2 times z squared. Notice nothing's negative now. So if you went into this thinking, oh, I've got negatives in my answer. No, you don't. You need to apply your exponent rules. So this is saying the same thing as the square root of 25. Well, the square root of 25 is 5. So that's going to end up giving us 5x to the power of 4. The 16 to the power of 1/2, remember, that is a root of 2, and then 16 to the power of 1. So again, that's just saying the square root of 16, so that's 4z squared. And that right there is going to be your final answer. So now that you've gone through these, and hopefully you did go through these before trying to do the homework assignment, Because if not, the homework assignment was probably unnecessarily complicated. Because as you see, as you go through these different pieces of these start to simplify, and they're not nearly as complicated as they look when you initially set your eyes on them. So at this point, what you want to do is you want to go ahead and do that 6.4 homework document. And what you want to do with that is just take your time to do that at some point over the weekend. Think about this as like something that's assigned to you on a Friday where it isn't due till Monday. So sometimes whenever you do your homework over the weekend, that's what you should be doing right now. So what's going to happen on Monday is I'm going to email out and post the solutions to that 6.4 homework assignment, and that way you'll be able to check your homework. Again, then you can email me with any questions you want to see worked out more clearly, and I'll post a video working through those. But then Monday's lesson is going to be solving radical equations. So how do you solve an equation that says like x is equal to the square root of 3 minus 4? So that's where we're going on next week. But for right now, again, you want to start working on homework 6.4. Again, make sure that you've done all the things that you're supposed to have done up to this point. Don't just jump in. There's a progression. So if you're haven't started yet, you've got the whole weekend to sort of go through this whole thing, and that's absolutely fine. But do that so that when you end up coming back in on Monday, we're going to be moving forward. So I hope this is helpful. As always, I am available to you, so just reach out. I miss you guys a lot. I hope this is helpful and that it makes sense. I feel like it's a lot like teaching in class, except that I feel like a crazy person talking to my computer instead of all you guys. It's not nearly as much fun. But again, I'm happy and I'm well, so I hope you all are too. And I'll check in again soon. Bye.